always start from the left-hand side and you have a shear force and you have your what? Bending moment. Okay. More importantly is what do we mean by positive shear and positive bending moment assumption? What do we actually mean? Okay, so it means like this. Now, when you perform analysis from left to right, so this is your diagram over here. So we did not do the whole diagram. This is your point A. Okay, this is where your point A, this is where your geometric datum is. Okay, so we know that this is our AY and this is your distance X. X is your what? Variable. Okay, now at a certain distance X, at this point over here, V will be going up or down. Up or down? One say up, one say down, the rest don't give a shit. Up or down? So this is when you carry out your analysis direction. So this is your analysis direction. So when you do your analysis direction, VAY is going up, VX has to be coming what? Down. And the moment has to be in what direction? Anti-clockwise. Now, if you were to do your analysis from right to left, right? So right to left, what does it mean? The geometric datum still stays. But now, this is your what? X. And now, you can see point C now. And now you have CY. The distance from here to here is L minus what? X. So now, your shear force is going up or coming down? Going up. So V as a function of X, moment as a function of X. This over here, the direction is what we call positive shear, positive bending moment assumption. Are we clear? Okay, so you have to know this. Okay. Now, have you all learned stresses due to bending moment? Hello? So now you come to a function where you have stress is equal to my over I, and we have a negative sign in front. What does M stand for? Moment. Okay, or more specific, bending moment. What does Y stand for? Anyone? Have you all learned this yet or not yet? Oh, my thousand apologies. This is where you have your point of interest. And what does I stand for? Okay, I do apologize you have not learned this yet. So what does second moment of area means? Your depth, second moment of area is equal to BD cubed over what? B with depth cube. The depth has been cubed divided by 12. Okay. Now, has a higher second moment of area? This direction or this direction? Remember what I told you. V, then Q divided by 12. That has nothing to do with English. I thought it was English. Okay? It all depends on the applied moment. If my moment is applied this way, this will be the width and this is the depth. So this is V. Is the depth of ruler? Is the depth of the ruler very thick or very thin? Thin, right? So something thin cube, the number will be very what? Small, right? So now, if I apply my moment this way, can you all see the ruler there? Yes or no? Now, if I was to orientate a structure vertically now, this is my width now. This is my what? My depth. Cube divided by 12. Can I bend the ruler? Right? You need a lot of. So, what is another term for second moment of area? Don't give me the math bullshit, okay? Let's say mommy asked you, hello son, what do you mean by I, second moment of area? You have to explain to mommy. It's the resistance to sending. Are we clear? Right? The second moment of area, layman's term is the what? Resistance to what? Sending. Okay. Is that clear? Why the formula is what? V, depth, cube over 12. Where the depth is depending on where the applied moment is. Okay. So over here, this is also resistance to bending. Because later on, when we do an example over here, okay, I'm going to do this example with all of you. We have to know. Okay, if you don't know the assumption of positive shear, positive bending moment, then we cannot do a problem like this. Are we clear? But this is worse, not worse, but you have what? Motion coming in, right? So you'll get the concept. Now, more importantly for us, especially in motion, we need to know, so this is now chapter 17. Okay, it is moment of inertia. Now remember, moment of inertia, which we also call it I, is not the same as second moment of area. It's not the same. Okay. Why? If we look at units, one is kilogram meter squared, and the second moment of area, the units is meter 4. So they are not the same thing at all. Okay. So now I've posted this diagram on Avenue to Learn. You can get it from the diagram. So now we have a structure. We have now this is now what we are learning over here is all to do with what? Again, rigid body. If the structure you are analyzing is not a rigid body, this is not applicable. Okay, so this is a rigid body. Okay. So now, G, as you can see over there, is the center of mass. Okay, G over there is the center of mass. Okay, and the structure is free to rotate about the z-axis. Okay, the structure is free to rotate at a z-axis with and angular angular acceleration of alpha. Okay. So from here, we can relate P is equal to I alpha. Okay. So T over here represent the torque. I over here is what we call the moment of inertia. The alpha over here is the angular of acceleration. Now, if mommy were to ask you, Sonny, what does it mean by moment of inertia? What are you going to tell her? Anyone? What are you going to tell her? So we just physically saw that I, second moment of area, is resistance to what? Resistance to bending, right? So what about I now? Resistance to what? Who say acceleration? Where are you? Is the resistance, okay, of the body for angular acceleration. Okay. And the units, I, it can be kilogram, meter squared. Unfortunately, I have to introduce this slug per feet squared. You'll be fine. I will explain better. Okay. Now, some of you like, Eugene, what do you mean by a slug? Right? Okay. Wait. So one slug is equal to 32.2 what? Pound of what? Force. Are we clear? So this conversion, you have to know. It is not that bad. Don't like, oh no. Okay. Okay. Then the next thing, any questions so far? I know. Yes, sir. Moment of inertia and second moment of area. Two different things. Yes. Angular acceleration. Okay. Yes. Huh? No, just slug. Feet square. Okay. So one slug is equal to 32.2 pound force. Are we clear? Remember the 32.2. Okay. I will give you the number in your final exam. Don't worry. Okay. Now, the next thing I want to focus on, which you all will learn, okay, which you all will learn. Now, how we do moment of inertia is also very similar to second moment of area in terms of how we do the calculation. Okay. Unfortunately, you all not have what are you all learning in 2P now? Are you all learning about torsion? Where are you now? Oh, Dr. Koshi is in the slow-mo. Then when you come to me, I have to dump a lot of crap on you guys now. I need to talk to him like, pali. That's in Korean, hurry. Okay. So the next one we are going to look at, I want you to focus on this diagram over here. Okay. Now, again, G represents our center of gravity.